Welcome to SynerJEE online classes. Today's topic is stopping potential. This topic comes under photoelectric effect of atomic structure. What is stopping potential? See, suppose if radiation falls on the metal surface, what happens in the photoelectric effect? Electron will be ejected out. Suppose if you connect these two plates to the terminals of a battery in such a way that the left side terminal LHS plate is connected to the negative terminal of battery and RHS plate is connected to the positive terminal of battery, then what charges will be developed on the left side plate, on the right side plate? Negative and positive charges. Now electron, since it has a negative charge, it will be attracted by the positive plate from the back side, in the back side direction, and it will be repelled by the negative plate from the front side. Therefore, the repulsion and attractive forces operate on the electron. Therefore, electron speed will decrease with time. It decelerates. Okay, and slowly it comes and it will come to a stop. Okay, so what is the minimum voltage required in order to stop the electron just before reaching the opposite plate? That means this plate. This is the opposite plate and this is the source of the electron. Now electron is releasing from here, and what is the minimum voltage you have to apply on the battery so that the opposite plate will be charged sufficiently to stop the electron to just reaching before the plate. So this voltage is called the stopping potential. If electron comes to stop here, this is called stopping potential. So stopping potential, therefore, we can write its definition in this way. It is the minimum potential, because if you apply more than this also, electron will come to halt, electron will stop, but not just before reaching the plate. Somewhere in between only it may come to the stop. But this is the minimum voltage required to stop the electron just before reaching the plate. So minimum voltage required to stop electron, photoelectron in fact, which is released from the metal surface before reaching negative plate. That is called the stopping potential. Now, so according to the conservation of energy, so initially when electron is released from here, when light hits on the metal surface, when electron is released, so the kinetic energy, initially there is kinetic energy of electron. So initial energy of electron is kinetic energy, which is half mv square, and when electron comes to stop here, there is no kinetic energy, and final energy of electron is equal to only potential energy, because there is no velocity, so therefore there is no kinetic energy and there is only potential energy. And that value, how you will calculate? Actually in second year of physics, you will learn that potential energy, when it is a charge q, when it is between the potential difference of v, then its potential energy will be at rest, its potential energy will be q into v. So since electron charge is denoted as E, so I will write E into potential difference between the plates, which is V. So in order to differentiate this V and this V, because this is the velocity and here this is the voltage, so in order to differentiate that, I will put VO here, which indicates voltage. Okay. So now, according to the energy conservation, so initial total energy must be equal to the final total energy. Initial total energy is only kinetic energy and the final total energy is only potential energy. So if I equate that, applying conservation of energy, initial total energy or kinetic energy of electron initial is equal to kinetic energy of electron potential energy of electron final. Because finally potential energy is the total energy and initially total energy is the only kinetic energy. I am equating the total energy initial to the final. So half mv square is equal to potential energy is E into potential, stopping potential V0. So sometimes the kinetic energy may not be given directly. It may be connected to the Einstein's equation which is involved in the photoelectric effect. So in photoelectric effect, Einstein has given an equation that whatever light energy is there, radiation, which is falling on the metal surface, it must be equal to the work function plus kinetic energy of the electron. That is the equation given by the Einstein. So sometimes they may not give kinetic energy directly in a problem. They may give you a work function and h nu, and they may ask you stopping potential. So now I will combine these two equations. So I can write kinetic energy of electron, which is released, must be equal to E into stopping potential, and kinetic energy can be written as, from this equation, h nu, or energy of photon or energy of radiation, minus work function. Okay. So by using this relation, we can find the unknown quantities from the known quantities. So this is a sample problem. A radiation of energy 3 electron volts falls on a copper plate and electrons are ejected. Now stopping potential is given and they are asking for the work function. Just now we have seen what is the relationship between work function and the stopping potential. So energy of photon hc by h nu minus work function is the kinetic energy, and this must be equal to E into stopping potential. So here it is given as h nu, this total energy, this total value, this is the energy of photon or energy of radiation, which is given in the problem itself, that is 3 electron volts. So 3 electron volts minus work function must be equal to E into 2 volts. Voltage is given as 2 volts. So what I will do here, E into 2 volts I will write as 2 electron volts and 3 electron volts minus 5. So 5 can be written as 3 minus 2 electron volts, which is 1 electron volt. Suppose in the options, if the answers options are given in terms of electron volts, then you can directly select. If it is not, then you can convert electron volt into joules also. 1 electron volt is equal to 1.6 into 10 power minus 19 joules. Using this factor, you can convert into joules and you can select the right option. Dear students, if you really understood the concept and if you think you really benefited from this video, then please subscribe, like and share this video. Dear students, if you want to take full benefit of these classes, please join our interactive live online classes. Thank you.